Hi guys, today we're going to talk about nuclear chemistry. So first let's talk about chemical reactions. Chemical reactions involve only an atom's electrons, so meaning the chemistry that's outside of the nucleus. So when we have a chemical reaction, the nucleus doesn't change. We don't change what an atom actually looks like. So when we make carbon monoxide and we bond one carbon atom to one oxygen atom, their nuclei don't change. That carbon stays a carbon, that oxygen stays an oxygen. But in nuclear chemistry, just like the name tells us, that does involve the nucleus. So the atoms of one of the elements will change into another element because we're involving that nucleus. Radioactivity is a process where a substance spontaneously emits radiation from their nucleus. Spontaneous, the word spontaneous, means that it doesn't require any energy from the environment. This is just going to happen no matter what the atom is doing or what the nucleus is going through. So atoms emit radiation because the nuclei are unstable. Either because there is too many neutrons or too few neutrons compared to the number of protons. So that proton-neutron ratio is off, and the nucleus of the atom is unhappy. And so it's unstable, and it wants to be stable. So the atom becomes stable by losing energy or radiation. When radioactive elements change into a new element, which subatomic particle is affected? Basically the protons. The protons are the ones that are going to be affected. And remember, protons are what make an atom a specific type of element. In that video, what is the job of the neutron? It's to hold the nucleus together. It acts like a glue between the protons, and also keeps the protons from repelling each other. And those neutrons keep the balance between those protons, keeping them in place inside the nucleus. So if there's not the right number of protons compared to neutrons, then we have that unstable nucleus. So nuclear stability, it is the neutron to proton ratio. We want just the right number of neutrons, not too many, not too few. So now we're going to talk about that there are three different types of radioactivity. Radioactivity is measured by passing radiation through electrically charged plates. So here we see a sample of radioactive material placed inside a lead casing, because radioactivity cannot go through lead. And we have a positively charged plate and a negatively charged plate. And as this radiation was passed through, it went in three different directions. Beta rays are negatively charged, so they went towards the positive plate. Gamma rays are neutral, so they just pass straight through. They didn't care about those plates at all. And alpha rays are positively charged, so they went toward the negatively charged plate. Here's a little more about each of them. Alpha radiation deflects towards that negative plate, so it's positive. Alpha particles are basically a helium nucleus, which is two protons and two neutrons, released from another atom that was unstable. So when an unstable atom breaks down into something else and it gives off alpha radiation, it is going to give off a helium nucleus. And here we see helium with a mass of 4 and 2 protons. We can also abbreviate it with the alpha symbol. So here we have beta radiation, which we know is negative because it went towards the positive plate. And it's a very fast-moving, negatively charged electron. Now, because it's an electron, we see that there's no mass change, right? There's no mass to this beta radiation. But we also lose a proton, as we can see right here, -1. So the atomic number is going to go down by 1 when that unstable atom decays into something else and beta radiation. And we can either abbreviate it with a beta or with an E for electron. Gamma radiation goes straight through. It had no charge, and it's very high energy. This is the kind of radiation that we get from UV radiation and X-rays. It has no mass. It has a very short wavelength and very high energy. Gamma radiation is the one that's really dangerous for us, and we want to try and avoid. So we're going to end talking about radiation by looking at the strengths of the different type of particles that a radioactive isotope can release as it decays. So here we can see an alpha particle is stopped by paper. It can also be stopped by clothing and skin. It's not very strong. A beta particle is a little stronger. It can go through paper and clothing, but will be stopped by glass or aluminum, most metals, and wood. Gamma particles are the strongest. They're the ones who can go through anything except for concrete and lead. So that's why we wear those heavy lead blankets whenever we get an X-ray, like at the dentist's office, so that we protect our bodies as much as possible and are only exposing the area, like our teeth, to gamma radiation that we want to be exposed to, and not all of our cells. And this ends our notes for radiation.